In question 8, we've been given a parametric equation and we've been asked to work out the gradient of the curve at t equals pi by 3. So we've been given x is equal to 2 cos 2t and y is equal to 6 sin t. So to find dy dx, we know that in parametric equation we need to do dy dt divided by dx dt. So let's look at x is equal to 2 cos 2t, and we need to differentiate this. So dx dt is equal to minus 4 sine 2t, and y is 6 sine t, and differentiating that we get dy dt is equal to 6 cos t. So dy dx is equal to dy dt, which was 6 cos t, divided by dx dt, which is minus 4 sine 2t. And then we've been told that t equals pi by 3, so let's sub in t equals pi by 3 into there. So 6 cos of pi by 3 is equal to 3 divided by 4 sine 2 lots of pi by 3, and that's 4 root 3, 4 times root 3 over 2, remembering that there was a minus there. If you simplify that, you should get minus root 3 over 2. Here we need to work out the Cartesian equation, and we can see that the parametric equation involves trig, so we're going to have to use our trig identities to do this. Y is equal to 6 sin t, but x is equal to 2 cos 2t. So let's think, cos 2t has 3 identities, but we notice that y is in terms of sine, so we should use the sine identity, which is 1 minus 2 sine squared t. In the question we've been asked to give the answer in the form of y equals f of x, so we need to make sure y is the subject. Well, y equals 6 sin t, and we've got the x in terms of sin t, sine squared t. Let's put it in the form of sine. So x over 2 equals 1 minus 2 sine squared t. Rearranging this to make sine the subject, we can say that 2 sine squared t, if we bring the sine squared to the left and take the x over 2 to the right, I get that. And so sine squared t is equal to a half minus x over 4. I think it's a good idea to try and make it a common denominator. So let's have it all over 4, and so it's going to be 2 minus x over 4 is sine squared t, and now we can say that sine t is the square root of that. Sorry. 2 minus x over 4. And now we can go back to the question and then see that y was equal to 6 sin t, so y is equal to 6 lots of this. Notice that our denominator is 4, which is a square number, so we could do the square root of 2 minus x all over 2, and so this simplifies to give us 3 lots of the square root of 2 minus x. The second part of the question asks us to find k, and we can see that the domain is from minus k to k. Because it's asking about the domain, we should look at the x equation. So x is equal to 2 cos 2t. Now let's just think about the graph for 2 cos 2t. For 2 cos 2t, That's the cos graph. Now if it's 2 lots of cos, we know that it's going to range from -2 to 2, and it's 2 cos 2t, so we're going to have shrunk the graph by a scale factor of 2 in the x-axis. So this is going to be, instead of being pi by 2, this is going to be pi by 4, and here we would normally be at 3 pi by 2, so it's going to be 3 pi by 4. Quickly just check the domain that we were given originally. We were told from 0 to only pi by 2. So where is pi by 2? Well, pi by 2 is that, so we don't need this section of the graph. Now let's look at the domain on here. If we've been asked to work out the domain, in the graph I've drawn, on the x-axis we've got t, and on the y-axis we've actually got x, and we want to work out the set of x values we have. We can see that x lies between -2 and 2. So k must be equal to 2. In part C, we're asked for the range of f of x, so when we're asked for the range, we need to look at the y equation. Y is equal to 6 sine t, but then we're looking at this between 0 and pi by 2, so our normal sine function just between 0 and pi by 2. And it looks like that, and it reaches a maximum at pi by 2, and the maximum it reaches is 6. So it goes from 0 to 6, so that's our range.